Good day, students. In this clip, we're going to be going over two examples on how to calculate coterminal angles in degree and radians. To get started, let's take a look at the definition of what coterminal angles are. So coterminal angles are angles in standard position and have the same terminal side. So that's what coterminal means. They're going to be in standard position on a coordinate system, xy, and they will have the same terminal sides. Coterminal, we know terminal means to terminate or end, co means together, so if they end at the same side, then that means that they are coterminal angles. So let me give you a graphical representation of what the definition of coterminal angles are. So let's take a look at this illustration here. We have two angles. We have angle CBA and CBD. So let's say that the small angle CBD has a measure of 30 degrees. All right, I want to find a coterminal angle, positive coterminal angle to angle CBD. Now notice what happens here. What if I rotate this a full circle all the way to here? Boom. You notice as soon as they have the same terminal side, even though they have different angular measures, they're considered coterminal angles. So what does this illustrate? It tells me that 30 degrees and 390 degrees are coterminal angles because they have the same terminal side when they're graphed in standard position. Okay, I can do the same rotation in the positive direction again. So another full circle. How many degrees is that? That is 360 degrees added onto the 390. And boom, we have another coterminal angle. So notice that there are infinite number of positive coterminal angles. The same goes in the other direction. Okay, now let's say we wanted to start with, let's make this 30 degrees again. And now we want to go in the opposite direction, the negative direction. So let's rotate this in the clockwise direction. So you see the negativity of the angle there. And then when we end at the same terminal side right here, you have a negative coterminal angle. So you have positive and negative coterminal angles. So 30 degrees and negative 330 are coterminal because they have the same terminal sides. So that basically illustrates what a coterminal angle is, or what coterminal angles are. All right, let's take a look at two examples. The first one, we're going to be following the instructions, which indicates that we are to find one positive and negative coterminal angle for the given angles and illustrate with a graph. All right, the first example will be an angle in degree measure. For number one, we have theta equals 75 degrees. Okay, we're going to do this algebraically first and then give a graphical representation of our results. All right, so first thing we're going to look for is one positive coterminal angle. So positive coterminal angle. So how many degrees did we have to rotate full circle to get a coterminal angle? We had to rotate a full circle, which is equal to 360 degrees. So we start from 75 degrees and we need a positive coterminal angle. We're going to add 360 degrees, which is equivalent to a full counterclockwise rotation starting from 75 degrees. Okay, so since we started from 75 degrees and we added a full circle, we're just going to add these two together, and that will yield 435 degrees. Okay, so this is our first positive coterminal angle. Now, how about our negative? We just want to find one negative coterminal angle. Coterminal angle. And then to do that, all we just do is we're going to rotate in the clockwise direction. Okay, rotate down and around. Just a full circle rotation in the clockwise direction is equivalent to subtracting 360 degrees from your initial angle of 75 degrees. And when you do the arithmetic, you end up with negative 285 degrees as your negative coterminal angle to 75 degrees. Now let's take a look at the graphical representation of the results we just came up with. First thing we're going to do is sketch the original angle theta. Okay, this is just a sketch. In standard position is not perfect, okay? So our initial angle theta is 75 degrees, which is located in the first quadrant, close to 90 degrees. So let's say that's theta right there. This is theta, which is 75 degrees. All right, our positive coterminal angle involved us rotating 360 degrees, starting from 75, 435 degrees. So to get our positive coterminal angle, we started from 75. So this right here is 7. Let's make this in black. This is the original one. 75 degrees. The first positive coterminal angle, we went, remember when you go up counterclockwise, that's adding, right? So we're going to go counterclockwise, that's 75, and then a full circle round right there. That is equal to, this is 435 degrees. That's your first positive coterminal angle. Okay? Now for the negative coterminal angle, we started from 75, and then we went down. Let's draw that. To draw that accurately, we're starting from 0, and then we're going to go subtract 360 degrees. So if we go from here and go round and end up here, this angular measure right here is negative 285 degrees. So if you look at these three angular measures, you can see that they all terminate at the same side. So we can clearly see that these three angles are coterminal angles. All right, let's take a look at another example. So for number 2, what if we have alpha equals 11 pi over 5? Okay, now we're going to find a positive and a negative coterminal angle. Let's start with a negative coterminal angle first. The negative coterminal angle. All right, so let's see. For a negative coterminal angle, we are going to be subtracting full circular rotations from the initial angle, which is 11 pi over 5. So starting with 11 pi over 5, we're going to subtract 360 from this. Well, you notice this is in radian measure. So how do we convert 180 degrees to radians? We multiply it by pi over 180, right? So 180 degrees is equal to pi radians. Okay? So we're going to be rotating full circle. So 180 degrees is pi, 360 degrees is 2 pi, right? So this is what we're going to be adding to indicate a full circular rotation. Okay, to end up in the same terminal side, we have to rotate 360 degrees or 2 pi radians. Since we're dealing with radians, we're going to be adding and subtracting 2 pi radians. Okay, so for this one, we're going to subtract 2 pi radians. Put this over 1. Now we have uncommon denominators. We will have to make them common in order to subtract. So we multiply this by 5, top and bottom, since the LCD of 1 and 5 is 5. So this becomes 11 pi over 5 minus 10 pi over 5. Subtract the numerators. We'll have pi over 5 Well, this is actually a positive coterminal angle, but we're looking for negative coterminal angle. So how do we resolve this? What we have to do is rotate another full circle in the clockwise direction. So that means we want to subtract 2 pi or negative 10 pi over 5. Negative 10 pi over 5 is the same thing as 2 pi, okay? So let's use 10 pi over 5. Subtract 2 pi again. And if you do that, you end up with negative 9 pi over 5. And this is one negative coterminal angle to 11 pi over 5, okay? So now let's indicate our positive coterminal angle. Positive coterminal angle. Well, guess what? We don't have to do any work because while we were looking for our negative coterminal angle, we stumble across a positive coterminal angle, which is pi over 5. So pi over 5 is a positive coterminal angle to 11 pi over 5. All right, so that's that. Now let's depict this answer graphically. Let's make a graphical representation of these three angles and illustrate the fact that they are coterminal. So we're going to start with the initial angle, angle alpha, which is 11 pi over 5. So how do we graph 11 pi over 5? Okay, so we know this is 0 degrees. This is also 360. This is 90, 180, 270. It's really easy to graph angles if you're in degree measure. Okay, so how about we change 11 pi over 5 to degree measure so it's easy for us to estimate where its location is. All right, so how do we change 11 pi over 5 to degree measure? You just multiply by the conversion factor, which is 180 over pi. Okay, so the pi's cancel out. 5 goes here 1, 5 goes into 180 36 times. 36 times 11 is 396 degrees. Okay, so it's easy to estimate where this is located. This is 360 and this is 450 degrees, so we know that it's in quadrant number 1. Okay, so let's put 396 somewhere here. It's like 30 degrees from 360, so somewhere here. Okay, all right, so what is the initial angular rotation? What does that look like? Initially, we had to go, starting from 0, went a full circle all the way there, and that is alpha, which is 11 pi over 5. Okay, now the negative coterminal angle involved one rotation in the counterclockwise direction. So if we went in this direction like this, like that, that will be negative, this one right here is negative 9 pi over 5. Okay, now the positive one, starting from here, just go like this, and this angular measure is pi over 5. And we can see that all these three angles are coterminal and they have the same terminal side. Okay, so that's that. So thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking here so you can get other cool clips, updates to other cool clips such as this. More clips can be found on math.serve.com, and do post a comment to let me know what you think about this presentation. Thanks again for watching and have a wonderful day.